On today's episode, sustainable aviation fuels work, but will they be adopted by the airlines? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. In the drive to create a zero-carbon economy by the middle of the century, multiple engineering solutions for the replacement of fossil fuels are in development. Power generation through wind, solar, nuclear, geothermal, and other carbon-free technologies are on the rise. But transportation, particularly air transportation, is a much more difficult problem to solve with alternates. Aviation is driven primarily by jet fuel, which is essentially kerosene, ironically the first large-scale commercial product derived from crude oil back in the 19th century. It's a relatively simple fossil fuel, easily made from crude oil by vacuum distillation and catalytic cracking, and when burned at high temperatures in efficient engines, it has all the hallmarks of a great fuel. Easy to handle, energy-dense, cheap, and safe. The production of CO2, however, is inevitable in any combustion process, and in jet engines there's no way to sequester that carbon dioxide stream, as there can be in ground-based power systems. Sustainable aviation fuel promises to remove something on the order of 80% of fossil fuel-created greenhouse gases by formulating the jet fuel from non-petroleum base stocks. Waste cooking oils, byproducts of agricultural production, in fact, any naturally derived carbon source can be made into jet fuel, and with enough energy input, it's even possible to make it from CO2 absorbed directly from the air. That process is energy inefficient, but the difference between aviation fuel derived from organic feedstocks is that the carbon it provides to the chemical process was pulled from atmospheric CO2 by plant growth, and is not the concentrated carbon locked into the earth for millions of years of plant growth and decay. Sustainable aviation fuel creates CO2 just like kerosene-based fuels, but it effectively does it in real time, recycling carbon from the atmosphere. This clean fuel is closer to prime time than most people realize. According to the International Air Transport Association, in 2022, 450,000 flights were made using SAF, and some 75 million gallons were produced. 38 nations have policies in place to mandate its use, and the industry committed $17 billion to forward purchase agreements, a figure the IATA expects to rise to more than $30 billion by 2025. Now, the organization believes that the use of sustainable aviation fuel could represent approximately two-thirds of the reduction in emissions needed by the aviation sector to achieve net zero by 2050. Now, globally, 50 airlines so far have experimented with these fuels. From an engineering perspective, sustainable aviation fuels work in current jet aircraft without the need to re-engineer engines. However, there are obstacles to widespread adoption. While there are multiple possible feedstocks, supply chains to deliver them don't yet exist, and the additional processing steps necessary to take things like agricultural waste and turn them into straight-chain and aromatic hydrocarbon fuels make them significantly more expensive. Now, with current technology, the only way to compel the global aviation industry to make the switch is to mandate their use politically, or tax petroleum-based fuels heavily, or subsidize the cost. Now, most analysts believe that consumers will pay more to fly in the future using sustainable aviation fuels. Advocates for petroleum-based fuels argue that sequestration and storage of atmospheric CO2 is a more sensible answer, since carbon dioxide can be remediated anywhere, including places where the energy to drive the process is cheap and plentiful. And the environment doesn't really care how CO2 levels are reduced, only that they are. Is the answer to decarbonization carbon-neutral fuels or net zero emissions through remediation? Now, engineering solutions exist for both, but economics and politics will decide. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.